morning, students. Welcome to the Science 1 class. Students, we have already learnt about colloidal solution. Let's see what is dispersed phase and dispersed medium with an example. Let us take the example of water and some fine particles of soil or dirt in it. Now, if the particles of soil or dirt are very large, then this will not become a colloid. It will become a suspension, because if the particles are large enough, then they will settle down at the bottom and we will have a suspension. But if the particles are very small, then they will continue to float, and then this will be a colloid and not a suspension. So let us take this example. Now these small particles of soil that are suspended in this colloidal, which may resemble something like a solute in a solution. So we can say that particles that are suspended in a following much similar to solute in a solution. Now these are not solute. You should keep that in mind. They are much similar to solute in a solution. These particles are called dispersed phase. And the solvent like thing is in which the dispersed phase is suspended much similar to the solvent of solution. So the solvent like substance in which the dispersed phase is dissolved is known as dispersion medium. In this case, the particles of soil that are suspended, they are the dispersed phase, and water in the dispersion medium. Now let's move on. Tyndall effect. Tyndall effect, named after physicist or Dr. John Tyndall, was the scattering of light only the suspended particles in something such as called colloidal. This effect is also referred to as Tyndall scattering. Let us demonstrate the Tyndall effect. We'll begin by filling or 3 beakers with distilled water. In the first, we will leave just the water. In the second, we will dissolve a spoonful of sugar, and the other will stir, add few drops of milk. First, we'll shine through the beaker containing only the water. Although we cannot see the light beam passing, it is through the water. We'll be able to see it as it emerges and change from the other side. Now we'll shine a laser through the second beaker containing the sugar solution. Once again, we cannot see the beam as it passing through the solution, but we are able to see it is emerges from the other side again unchanged. Finally, we'll shine our laser through the third beaker, which has milky water. In this case, we are able to clearly see the light beam as it passes through the liquid. This appearance of light beam passing through the liquid is the result of Tyndall effect. What is happening to the light beam? Take a close look and watch each beaker so that we have better understanding. In distilled water, any particles are too small to obstruct the path of light. As it passes through, we won't see the beam. The solution, such as sugar solution, we made is a homogeneous mixture made up of only one phase. In this form, the solute, in this case, the sugar will dissolve in the solvent. In this case, the water taken the characteristics of the solvent, meaning once again we won't able to see the light hitting anything. But colloid, however, has two phases, the dispersed phase, which is milk particle, and the dispersion medium, which is the water. In the colloid, light will scatter in different directions due to the dispersed particles. But in water and in true solution, such as sugar solution, it will pass through without being scattered. The Tyndall effect is used to identify whether a liquid is a solution or colloid. Now, let's move on. Brownian movement. The continuous zigzag motion of fine particles suspended in a gas or liquid is called Brownian movement. It was discovered in the year 1827 by the botanist Robert Brown and it's named after him. For example, let us observe the beam of sunlight entering a dark room. You will find that the dust particles are continuously moving in a zigzag manner, which makes the dust particles move continuously in air. You already know that air is a mixture of gases and gas molecules are always in the state of free random movement. These molecules hit the dust particles from all directions and make them move in an irregular manner. Similarly, if pollen grains are placed in water, they do not remain at rest, but they move about continuous and randomly. This is also an example of Brownian movement. Thank you, students. Have a good day.